Hello. It's been a little bit. I now have to remind myself where we were. Here's next time. Okay. Function decls from snippets work now, right? We did that last time. Weird edge cases. The main thing is see both to-dos in parse function or variable decl. Let's see. There are apparently to-dos in here. This case doesn't early out, so it should really... So should it really be here? Okay, so this function has some special cases that we early out of. So if we see an asterisk after the parent open, it's a function pointer. So we hand that off to another function and just return. If we're in a struct and we see that the name of the... Okay, so that's constructors. So what is this case? A struct template decl. So that would be like this. We'll say like in size, I guess. And we're gonna make this U8, and we're gonna say like a bunch of U8s of type or of size. So does that work? No. Incomplete code path. Right. Because we see it here. We don't early out, so down here I'm guessing yeah. So we're hitting this because we were expecting to have earlied out there. So if it's a templated struct, why are we here in the first place? Why are we here in the first place? Parse struct. Here. So, where are we? Peak token. If its text is equal to our name. Oh, okay. So this is literally what we're saying. If we see the name followed by an open paren, or it's a tilde. Okay, I'm a little confused. This is in parse struct. Oh, okay. This is okay. If we see a keyword, then it could be a struct, it could be a union, could be a operator overload, fine. If it's not a keyword, then we look what's after the thing that we saw. If the thing is a name of our struct, and the thing after is an open paren, okay. This is once we're inside of the struct. This is not what I should be looking at. We grab the token struct. We create a struct node. If it's a named struct, we do that. Here's where if the next type is a paren open, we grab the decls. Okay, not quite sure what's happening. Oop. Okay. Just to make sure that we're hitting this, there, struct, and then we're hitting parse function or variable decl. Why, though? Because we should see... We're hitting this, which is right, because we see a variable decl there. Parse function or variable decl. But why are we hitting... So this is not even the templated part, because we're not even hitting the templated part. This is just a variable decl inside of a... Alright, it's none of our early out cases, right? It's not a paren open. It's not a keyword. It's not a tilde. Okay. So we're just parsing a regular variable here, so why are we failing? Wait, what? Skip the type. So let's just make sure we got the type. Let's make sure we see the type. Right, so we got U8. That's fine. We're trying to identify what this thing is here. We skip the type, so here we see an identifier. Okay, we just skip right past it, right? We don't care about those. Oh. Oh, that's why. If we see a... right, this code just doesn't understand. If we see an open brace... then this is just an array variable, but equals implies a variable. Oh, so does this. Okay, we'll just do this. Equals or square bracket imply a variable. So we'll just do both. Okay, Well, we're crashing, but we're getting past this part at least. It's not a function decl, it's a variable decl. And are we getting here? Parse variable decl. Let's go there. And get its name. Identifier. So we'll, God, I don't remember how we do this. Can we just print an identifier? Identifier. Don't think I have a good way to just print it out. I can print node nicely. I think that might work. Maybe. That might work. Identified. Variable node, where did I see that? Here. After this, let's just print node nicely, variable node. And I don't think that does a new line. Oh, we don't do that in the parser. That's a code gen thing. I hate having these in different places. Print node nicely, yeah. Okay. What is get node identifier? Get node identifier. What does that do? That gives us an identifier node. I just want to see what this thing is. So, identifier, parse name right there. So, print identifier, and we'll just say this thing. We'll just make it. How about we make it? Print token. We'll have a print identifier. Okay. I gotta remind myself how we do these things. Identifier node. Okay. Each one's a node. It either has text or a node to print. So for now, I think you say if identifier node. If it doesn't have a node, we can just write output identifier text and a new line. Otherwise, we have to starts identify. Is it construct identifier? Oh, construct node name. Oh, that's what I wanted. We already have that. Okay. There, that's what I want. Construct node name. So forget this whole thing. Let's go back to where we were. Let's do that. Construct node name. We're gonna do variable node. That's all I wanted to do. And you know what? Let's do that with what does construct node name do? We'll do this. Short string construct identifier. Oh. Identifier string. Oh. Looks like okay, you know what? Let's not complicate this. It's fine. Write output, and we will pass. We'll just do this. This, and we'll say print identifier variable node. Print node identifier. How about that? Okay, that's fine. Does this have a backend thing? It does. I forget what that does. Backend just preserves things like concat in names for when printing the AST. That's fine. We can do that. Print identifier. Nope. Okay, so we're actually crashing at X, not even the thing I just made. So let's go back there. We're crashing here now? Just because this thing exists? No, we're not crashing there. Although... Oh, we're probably crashing at... This parse variable decl is probably where we're crashing. Before... and after... Well... Wait a minute. Here's values. Is that the only values in here? Yes. Okay, we are parsing that actually, but it's now... Having that uncommented causes us to crash. Why? Okay, let's debug this. Let's go to the parser and let's just see where we crash. It's in parse struct. Next is null. Okay. So I'm not handling something correctly in here. In parse struct. Let's just see what that is. Struct node. It is a decl struct. Identifier. It doesn't have an identifier yet. Oh. We haven't done that for them yet. It's still name, so templated. Okay. Brace depth. Okay. We're going into it. Next is a curly open. Great. It's a curly open. We keep going. Now it is an identifier called U8. It's not one of those. It is one of those. We parse a function or variable decl. Boom. Var decls. It gave us one back. It's a variable decl called values, whose array dimensions is 1. So we are parsing this properly, and the array sizes is a decl ref, and this should say sizes. Or size, yeah. Okay, that actually worked. That's working just fine. So why are we crashing? For for each one, add a child node, that's fine. Next is a curly close. Minus minus brace depth and advance. If this struct has no children but still has braces, we don't want to consider this a forward decl. Wait. Oh, because we don't give it a compound statement until... Wait a minute. Why do we not just always give it a compound statement? Parse struct compound. Oh, we don't give it a compound statement. Duh. It just has children. Okay. That's a little weird, but whatever. Now we're gonna say... Let's keep going. So next was the curly close. Okay. We should be done there. And we're not. Because when we hit this close brace... Why are we not done? If brace depth or not brace depth and... I don't get what this and is for. We only stop if... Or we only keep going as long as we have more braces to break out of. Or, if we don't have any more braces to break out of, if it's a semicolon or an identifier, why would it be though? Here. Don't quite understand that. If we see a curly close, I'm trying to understand what... Okay. Either brace depth, so we have more braces to unpack, or we don't, and as long as the next is not a colon and it's not an identifier. If it is one of those two things, we keep going. Why? We do this next. In that case. I don't understand this. When would you ever have... Okay, let's just try removing this thing and just see if it explodes on us. Actually, let's do it this way. What was this extra bit doing? Why do we keep looping in those circumstances? If we are fully out of the compound statement for this struct. What could possibly be next, keeping us looping? Metastruct template should not be forward declared. It thinks this is a forward decl for some reason. Does that need a semicolon? No. No. Well, I do put it there. Hold on. Am I crazy? Do these things need semicolons? Am I just... I mean, I use them. Maybe I'm just crazy. I mean, that didn't fix the problem, but... let's see what this does now. Should not be... should not be forward declared. It's in reported by the metaprogram at location. Should not be forward. This is in code gen. Struct templates, right? Yeah. Update struct templates. For each struct, is forward decl. Is forward decl. I think that just checks for children, does it not? Yeah. Which there's no way this doesn't have children. Like, clearly. Can print out the tree too, and even... Or can I not? Is it not dash T? Dash T? Yeah, it is. Okay. Very confused right now. Okay, so that does need a semicolon, but oh, okay, it does in fact need a semicolon. That's why that's there. That's fine, but I don't get the identifier part. What is the why do we also condition this on an identifier? Okay, so that was just me being dumb. I was missing a semicolon. That's fine. Should really be able to point that out and not just crash. Does that happen with normal structs? Yes, it does. Okay. Why would we condition this on an identifier? I really want to understand that. Identifier. If it's an identifier... I guess it's because you could do this. Right? Yeah, but let's just, for now, I think it's to support defining a struct and declaring an instance of it simultaneously. Also say that because I don't feel like spelling that right now. This doesn't seem like it's even working right now. So for now, I'll turn that part off. How about that? Okay, we're back. So, can I do like templated 5 and then print size of let's do this. Size of divided by size of the whole thing. Instance. So size of the whole thing values divided by one of the things. This should give us whatever we passed in here. Update function call if macro. Okay. That's this, I think. Is that not how we do that? No, it is. So what's wrong with that? Let's go look at what we generated. And can I do that without line numbers? Is that in? Yes. Oh. We just don't handle that right now. That just didn't get expanded. That was definitely working. I wonder if this identifier stuff has messed with that. That seems bad. Template, struct template. Let's update struct templates. For each struct, let's just print node nicely. Node. Let's just see if we see them. And we will do this. Okay. There we go. We see one. So we recognize it as a template. That's great. Meta struct template. Let's look at what the tree's doing. There's our template. We pass it a size as a parameter, and we use it in the array. Where is it? Here. Decl struct constructor. That's wrong. It thinks this is a constructor. Interesting. Why? That should literally never happen because we're inside of a function. Why? This is all fine. This is all correct. This should not be a constructor though. That should be a struct template call is what that should be. Struct template call. Wait, what did I... Oh. Oh, that should be on the function call. Right. Wait, what? I do that in the parser? Yes, I do. Because we can recognize it when we're doing... Okay. Parsing a variable decl, which is what that thing is. Okay, I'm trying to remember. It's been a while since I've done this. So this is a variable decl. We've identified that. And if we see... After the type... If we see an open paren... it has to be a struct template decl. So we give it the property. That's a variable decl node. How is that getting turned into... Where is that getting turned into that? How is that possible? Function decl type. We're not there. Constructor, we're not there. Dude, how is that possible? Is there a chance that my names are off? Let me just update this. It sucks that you even have to do this, but there's a chance I forgot to update these. Okay, and then we will turn these into strings. I don't think this is happening because it would be way more off if it was. Yeah, this is becoming a decl struct constructor. That's that is so wrong that how is that happening? Am I really just am I writing this incorrectly? I'm not. Struct name. What if we make this just a regular struct? Okay. No, that did work. It just doesn't know what a U8 is because I forgot we're in test land. Yeah, okay, it knows what that is. It doesn't know what this is, though. Templated wasn't declared. That's fine. Yeah, there it is. Decl struct constructor. Where do we set this at? Let's just do this in the parser. Decl struct constructor. Let's just set a breakpoint at each one of these. And see which one we hit. Parse function decl. Which is... Wait, what is this? Return type. Oh, I'm literally, okay. I'm looking at this and thinking this is a function. Decl? There's no, what is happening? What is happening? Where are we? Line 6. Column 12? What? What? What are you talking about? Where are we? Line 120 is where we are. Yeah, we're here. We're parsing a function or variable decl. Oh, we think this is a function decl. That's why. Why do we think that? I must have broke something in here. Oh, is this literally what this to-do is here for? It is. This is what this is here for. Oh my god. I need... It's been too long since I've looked at this stuff. That's what this to-do is saying. This is bad naming. I thought this was a... I thought this was this case. But it's this case. So... all this is doing is skipping over... Okay. If we're in a decl struct, otherwise, what is this doing? Skip the final closing paren. This just wants us to skip past. It wants us to get to here. Which I think it does next. Skip ahead, index. Let's just print token next. Let's not print the tree anymore. Let's get rid of those. Do I even need those anymore? I don't think so, but... values. Main, x, open paren. Yeah. We skip past this, and we immediately hit that. We're not skipping past what we're supposed to be skipping past. So, let's just remove this case entirely. And then variable decl or function or variable decl. So see if we get the type properly, which we do. There it is, templated. And then in that case, we need to hear. We skip past pointers as like asterisks and ampersands. So this should still work. If we see a paren, see if the parameters are typed or not. If they are, it's a function decl. If they aren't, it's a variable decl. They will not be typed here. So let's go through this now, because that should be working. So let's get rid of these. And function decl here. Function decl. Let's do this. We're gonna say let's recompile. Okay. Here we go. So look at the peaked token. It's an identifier called underscore. Wait, where are we? Int. Wait, what? Where are we? Hold on. Type is int on line 81. Oops. We're in the wrong spot. We need to be down on line 120. Here we go. Okay, is this a function decl or not? Let's look at peaked. Peaked is a parent open. It's a parent open, so let's skip past it and look at the next thing. It is an unsigned int. If it's a parent close, there are no parameters, so we have to do a little bit more work, but it's not one of those. This is not relevant right now. This does need to be fixed, but that's not relevant for what we're doing here. It's not a parent close and it's not a comma. This is a unsigned int. So all we're doing is counting identifiers here. Function decl. Oh, okay, yeah, we're counting to see how many things you pass to it. So, like, if I did this versus I'm counting how many things are in between, how many identifiers make up a single parameter. So if I hit a comma or a close paren, that's when I stop. In this case, I'll only count one thing. In this case, I'll count more than one thing. So that's how I'm determining if these things are typed or not. So if there's at least 2 tokens that make up a single parameter, I'm saying it's a function decl. But in this case, I shouldn't be. Token count is 2, though, which is wrong. So let's go back here. Let's edit this and say that next line number, is it just line? It's 120. Yes. Okay. So let's see why that's happening, because it shouldn't be. Okay, it's not a parent close. Token count is 1. And our next token, peaked, we've already counted that, right? Token count is 1. Oh, okay, I think we're overcounting it. We've already seen that. We skip past it and look at the next thing. It's a comma. Okay, yeah, this logic is just wrong. We're gonna say function decl equals false. Here we go. I think this is just incorrect, and I think I wrote that last time and didn't. Okay, we can probably leave that there and just say. So in this case, we've got unsigned int. Oh, wait, hold on. I actually didn't have that right. Let me redo that. No, okay. 108. Yeah, okay, we screw that up now. So I think that does have to be 1. But in this case, token count is 1. If the next thing is not a parent close and it's not a comma, wait, why is it... We're not properly skipping past this open paren. That's what's happening. We're not properly skipping past that. So if we see an open paren, let's do this again. Peaked. It's an open paren. Great. We skip past it. Peaked is now an unsigned int. It's not a close, so we've counted the unsigned int. We skip past it. Peaked is a paren close. Yeah. If we see a paren close after we do that, we need to stop. Basically this same thing, right? And really what we can do here, do this, and turn this into a do while. Then we don't have to do this. So what did I do? Okay, so unsigned int, we count that. We skip past it, and then so long as there's not a paren, close, or a comma, we if there is a paren, close, or a comma, we know we're done. If there's not, we just parse a type, and now we have to parse a name, so we do that. That's what we do. Okay. Let's see where that got us. No lines. Okay, that's still bad. Let's look at the tree. We still think it's a... Okay, we still think it's a function, so let's see why. I think we're closer, though, than we were. So, token count is 1. It's an unsigned int that we saw, so we skip past it. Oh, no. No. Man. What is wrong with me? We don't do this unless... Okay. Yeah. There. That's what we need to do. Pretty sure. Yes. Jesus. Okay. Now we see it as a variable, right? We're not compiling yet, which is fine. We at least got this part working, though. So, it is a variable decl. It's called instance. Its type is templated. Okay, what does that spit out now? No lines, please. Okay, so now we're just not creating the struct, right? What should be happening here is this should be creating one of these with an 8 there. It should be making this, right? And then down here, this should be one of those. That should be happening automatically, and it's not. So if I do that, Well, it's going to recompile anyway, so it doesn't matter. We're not doing that, though, for reasons that are probably totally valid, because I don't know if I left that in a state where that's working. Okay, so our struct template's supposed to be broken right now for code gen. Variable, decl variable. Print node nicely. Let's see if we give this thing the proper tag, that it is a... It's not a function decl, so we parse the variable decl and give it its flags. So, are these flags... It has no flags. Did I remove... property... What is it? Struct template call. Parse variable decl. Oh, okay, we do it in there. Okay. Alright, let's see. Once we see that it is a variable, we parse it. Wait, which means it should have had it. Hold on. That should have had it by then. Let me make sure we're on the right thing. Next. We're 120, we're fine. Parse variable decl. Boom, 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 boom. Boom, boom. Okay, type is templated. It's not a type any. Peak token. What is next? It's an open paren. It's none of these, none of these. It's an open paren, so we give it the struct template call. We do that. We do. Variable decl node. Info. Decl variable. There it is. It has the flag. Okay. It is definitely tagged as such. So property struct wait, property struct template call. Oh, it's in the metaprogram. Okay, that's fine. Let's just do this real quick. Print node nicely. Decl. Let's just see if it shows up here. It should. Wait, we don't have that there either? What? In the metaprogram? Really? What are you talking about? What are you saying? Just give me the function, please. Try to append string on an uninitialized. Okay, we're not even making it there, so that seems bad. Let's just see why we're breaking there. Tried to append string on an uninitialized. Tried to append string here. This is in string builder, so let's go to string builder. Let's go here. Why are we hitting this? Parse function decl. This is in the parser. But we're in the metaprogram, so we're not actually in the metaprogram. I don't think. Almost certainly a function decl, so we go, and where are we here? Coefficient, we're all the way up there? What? We're failing like up here. Okay, hold on a moment. Let's remove this stuff and just see if... see if we are actually working, and it's just something that is... some interaction here that it doesn't like. Okay. Okay. So that's actually fine. That's a different error that we're hitting. We're just not generating these. So let's go back to the metaprogram and do what we were doing. This is in code. All these printing functions are in code gen. They shouldn't be here, I guess. All of these can be in... common? I don't want it in there. The lexer, the parser, it should be in the parser, I guess. Let's do in God, this sucks. I hate this. Let's just put it with these because everything's horrible. Exempt from unknown tag. You know what? Let's have a place for printing. Specific place for it. Because I'm tired of this being a problem. Here, all the way down to here. And we're going to make a new meta gen print. There we go. These are all going to live in there. And the exempt thing is also going to live in there. And the parser.h, the parser itself is going to include it here. Is it .cpp? Is that what I just called it? Yes. In keyword function call, we need that. In keyword function call, we need this thing. This is all just like, this is all really stupid that this has to even be a problem, but construct node name. This can be for declared in here. Pipe bold, okay, all those things. Pipe bold is all of these. Can go in here. Get numValid children. I'll just forward declare this in here. Oops. What did I do? 492 in the metaprogram, right? Great. Redefinition of in keyword function call. Wait, what? Code gen. Oh, I didn't save this. Hey, look, we're back. Okay. So back in the metaprogram, let's do what we were doing. Print node nicely. Let's look at all the variable decls we have. We don't have any there. Okay. Generate struct templates. Oh, well, having them turned off is certainly going to make them not work. You know, if they're turned off, they are not going to work. Now, will they? So let's go back to printing this. Hey, look at that. Okay. Let's figure out why we're crashing. Get type name from generate struct templates. So, the info is a wait, hold on. This decl is a variable, right? Whose decl variable is instance. Great. It's got the flags on it, so we found it. Its type node is a struct template. Great. So we try to get the type name from its type node. Get type name from node is null. It's right here though. We passed it info type node. It's right there. We passed it this. So why are we crashing? Info wait. Hold on. Variable. Info. Decl variable. Identifier. Instance. Info. There it is. Type node. Member name is values. Member, and it's a, okay. Okay, that's weird. Why are we crashing there? We're passing it info type node. Info type node is null. Even though info, oh, this is for the child. Oh, this is for the child. Here we go. It's a struct member whose type is int and has no type node. That'll do it. Get type inf or type name from. If not node, return node. Is it just type? Oh. Hold on. That's what we'll say this. We'll do it right here. Where are we? Where are we? We're in the metaprogram. Here we'll say the member type. Where do we even use that? We aren't using that. If okay. If info type node. So if it has a type node, get its member type from that. Right? And then this can be member type. We don't have to do that again. Yes. This can also be member type. Okay. Okay, we're back to compiling. Not working yet, but we're back to compiling. Hey, okay, we created the struct now. That's good. Wait, are we working? Did I read that wrong? Oh, we're working. Unused variable. We're working again. So if I print this, I should be able to see an 8. So we're basically saying instantiate one of these structs called instance and generate one that has a size of 8 and then just print me the size. That doesn't work. Interesting. Okay, why? What are we hitting? Update function call if macro in CodeGen 95. Interesting. Update function call if macro. Let's just see what we're doing here. The function call in question is here. It's printf. So this is the printf, which is what we want. It's got an expression. It is a decl ref. Name. Do we crash there? No, we got a name. I always worry about that function. It's printf. Okay. For each node of type in tree. For each Preproc define. Oh, we're seeing if this is a macro. Which it's not. Okay. We're hitting one whose type is not a decl ref. Somehow. That second one is not. Why? What is this one? Function call. Keyword. Oh, it is a keyword. I think because I don't have, yeah. Okay, the way this language is going to work is you have to forward declare, or you have to declare up front anything that is external. So if you're using stuff from the C library and you include those, you have to make just effectively a forward decl for them. So like I make forward decls for like in Linux for all of these different handles. Memory map, anything I'm using, right? I'm making them here. And in the code, I think I'm making a size of, which is why I'm a little surprised this is not working. Insert synthetic keyword nodes, right? I'm doing that right here. I'm inserting synthetic keyword nodes. So insert synthetic insert synthetic keyword nodes. If I do that, does this work? No. It does not. Okay, what if I create one? Here. And I do a external printf. I forget, does that need, yeah, it needs the types. So, ooh. Printf is variable though. Ooh, that's no good. Oh no, I don't need printf, I need size of. Hold on. Wait a minute. Insert synthetic keyword nodes is what I need. Insert synthetic. We create a size of node. It's a decl function called size of. Returns a U64. And I say it's external. But it does take a parameter. Let me see if we are hitting. Okay, this is the part of this that's not fun because I don't. Connect, find and connect decl ref. Let's do this. Connect decl refs. We'll look for function calls. Really, we don't even get there? Connect decl refs. Let's just do that for all function calls. Really? What? What am I seeing here? Ah, why is this terminal so screwy? That's like useless. What is this output that I'm seeing? What is happening? Stop. Okay, whatever. We're not hitting this. We're not even hitting that. We're hitting... what did I say that was? What was this in? Update function call if macro. Crap, but we need... The problem is, where are we setting these up though? We're setting up its expression, right? Is that in the parser? Parse as function call. Move this stuff to code gen. I don't think that matters. So let's go to parse as function call real quick and see what shows up. Okay, the expression should be a decl ref printf. Okay, so that's it. We get the open param. We parse the call params, which is we parse another function call here because size of is in those call params. So this keyword here is the size of keyword, right? So this function's calls type is a keyword. That's why. Question is that okay if this is a keyword? I wonder, is that just okay? Yes, okay. Construct node name. From unhandled type here. Do we have keyword in here? We do, I just never did this. Okay, let's keep going. Making progress. So if it's a keyword, to do identifier here, we'll just return node info expert keyword name. Update call if snippet. Okay. Same thing has to happen there. Right? The same thing can happen. Okay, no longer hitting assertions, but we're still crashing, so that's fine. Get rid of this. What? Reset arena. What are we? What? Did I not? What? Global parser. Scratch space. Whoa. Wait, what? Okay, something very strange is happening now. What? I'm doing something to the memory here that I should not be doing. What? How do I even start with this? Why? This is on the second time through. Second time through. We are... Yeah, we're running the metaprograms. Okay, hold on. Let's... not do this. Okay. So doing this causes us to flip out. We just explode. We explode here. Let's see why. I forget. Do I have to run the actual program instead of here? No, I can do it here. Okay. Okay. Metaprogram, boom. Okay, generate struct templates. Decl is, we're gonna do this until we hit here. We're gonna go until we hit. But wait a minute, we're not even doing... That's not even... Okay, hold on. Let's get rid of this. And just have this be 8. And get rid of this. Do we still crash? Okay. Right? I can't do this. It's gotta be a... We're in this world. That works. If I make it this, we crash. Okay. Why? Something in here it does not like. So I think we're fine here. We actually do generate the template, don't we? Yes. Generated node is decl struct, whose name is templated underscore 8. We do generate it. That's fine. Done. Done. So we run this a second time. And we crash at that point. The second instance of the metaprogram that runs on remaining nodes is 1. We just generated a node for templated 8, and we want to run the metaprogram on that. And this output source node is secondary chunk 1. Correct. Why does it not like us doing this? Global parser, arena, that seems to wait. How did we lose our scratch space? Wait, what? Global parser, scratch space. Scratch space. We lost our scratch space. Why? How? What? Who? What? What happened? This happens in Lex, parse, and run metaprograms. Global parser is Lex, parse, and run metaprograms. We parse the lex. We build up all the. We parse all of our lexers, and then we give it the scratch arena. Yep. Run metaprograms. Who is changing you? How are we losing that? I don't understand. Is it the metapro? How is the default metaprogram? Generate struct templates. It must be happening in here somewhere. But how? All right, can we do this? Here it is. We still have it this whole time. We lose it. So we still have it this whole time. Back out. We don't have it by the time we're back out. Why? Somewhere in here we're losing it. It is the default metaprogram. What? How is the default metaprogram wiping out our... How is that possible? I'm just gonna throw some things in here. It's gonna be something really stupid. Still have it. Still have it. Still have it. Still have it. Add struct decl to program. Right here. We lost it. Here. Yes, that right there. Move this. Remove this. Create source node from code. Lex source code. That didn't do it. The scratch parser. So wait, what? This is the temporary parser that we create to parse oh, do we just not give it a scratch arena? Yes, I took it out of here. Yes. Yes. I make this the global parser. Yes. Wow. Holy, this does suck. You're right, past me. Memory arena, previous scratch parser, global parser scratch space. Global parser scratch space equals previous scratch. Okay, we're not out of the woods yet, but wait, what? Oh, if we have a global parser, we have to do that. Otherwise, we can just do this. Alright, well, at least we're compiling again, but oh my god, that's awful. Oh, and we're actually working now. So if I create an instance of this that's 16, our size is 16. Okay, we're back to working. Holy crap, though. That sucks. Can I turn all this other stuff back on and we're still working? Yes. Oh my god. Okay, what a pain in the ass. So I didn't actually do this, which is what I wanted to do. It's what I started tonight doing. I had to fix... I turned struct templates back on and made them work after all the changes I've been making. That's really all I did tonight. But that was gonna have to happen eventually, but so where are we at with this? Parse function or variable decl. The to-dos in here. I think I fixed identifier count. I think this logic was busted, so I fixed that. We still have to do that to do. We got rid of this to do up here, which is great. That's great. Because we don't early out anymore there. We catch templates. Where do we catch them now? Down here. Function decl is false. We catch it down here. This logic should have been catching it, which it definitely does now. So, and I turned templates back, struct templates back on, and they seem to work. What if I make a type, and I do type? Does that work? Incorrect number of arguments. Got 2. Expected. Oh, expected 2. Got 1. So this can be like int. Back. We should be back to working the way we were before. Unable to resolve parameter int. Because it should expect keywords. Unable to resolve parameter. Decl node. If I'll make a to-do for that. What if I do this? If I try that again, it doesn't know what U8 is, but if I do like a type def unsigned int U8, U8 does not name a type. You sure? You positive about that? Let's do this with outline numbers. Oh. That should depend on that. Why does it not? Depends. Node depends on. If it's a struct, where's my struct? Decl struct member. A depends on B. Node depends on. So, if I'm a struct, then look at all my children and see if they depend on a certain thing. So the struct member, if my type node, oh, it doesn't have a type. No, it does. If it's type node, equals B, which it should be, because... Okay, there's that size of. I don't actually think we need that. So let me synthetic keyword keyword nodes. I don't think we have to do that. So where are we? Decl ref is a U8. Okay, hold on. Here's the type def. It's U8, which is an unsigned int. Here's the template. Great. That should depend on that, and it doesn't. I guess I'll make another note of that. This also doesn't work. This should depend on I imagine I broke a lot of the stuff in the pursuit of doing all this identifier stuff, and I bet a lot more stuff will break as well. But that's fine. Once I get back to this, it'll start coming back together. This doesn't the struct this generates does not properly depend on the U8 type def. Note, if I use int instead, it won't have a type node. Does this work? Should work if the type is fundamental. Okay, let's just call that good, and let's say turned on struct templates and fixed some issues, more to-dos. Okay. Fixed issues with struct templates after re-enabling them. More to-dos. Okay, this is definitely a sluggish part of this process, but slowly turning things back on and fixing the bugs there is necessary, so is what it is. Getting there. I would be a lot farther along had I not taken so many breaks, but that's fine. It happens. So yeah, thanks for watching, and I will check you all out next time.